Mix 6.2 notes. Okay. Cool, okay. So that last section we talked about in 6.1, that was all about multiplying and dividing rational expressions, right? Which is a lot like, they're fractions, right? So it was a lot like just multiplying and dividing fractions. Okay, it's just a little different, right? Because now there's x's in your fraction. Now there's x's in your fraction, okay? So now we're going to talk about adding and subtracting rational expressions. Adding and subtracting rational expressions, okay? Okay? This is just like, so to add or subtract, right, you just make sure there's a common denominator. And then we're going to add or subtract across the top, just like with regular fractions. Okay, so for this first one, do I have a common denominator? Yes. Yeah, they're both x, right? So I do what? Just add across the top. So it's 11 over x. Okay? Boom. First example in the books. In the books. Okay? Done. Done. What about the second one? Do I have a common denominator? Yes. Yes. Look, the denominator is the same, so it's really easy. So I just do what? Subtract across the top, right? If we wanted to, the directions don't say this, but if we wanted to, we can simplify this, right? So we can factor the top into that. All right, we can factor the top into that. Then this, setting the bottom equal to 0, gives us this excluded value. I'm going to go through this fast because we just talked about it. Cancel that. So if we simplify, that'd be our final answer. The directions here didn't say to simplify, so I'd take that as well, but make sure you read the directions, okay? Make sure on the test, if I ask you to simplify, you need to simplify, okay? This last one, what's going on for my denoms? Are they the same? They are, so we just add across the top, okay? So we're going to have 8x minus 5 plus 7 minus 7x. We just add everything. Okay, let's combine our like terms on the top. That'll give us x plus 2, okay, and over x squared plus 6x plus 8. I'll take that as the answer, right? If the direction said to simplify, we do what? We got to factor. So the bottom factors 2, I believe it factors 2. All right, so our excluded values, right, that'd be x equals negative 2 and x equals negative 3 get excluded. Right, and when we cancel, we get 1 over x plus 3. Oh, did I do something wrong? Sorry. I'm so sorry. That's 4 and 2, sorry. Thank you. I did it on purpose, just trying to make sure we stay on our feet. Sure. Alright, so it's 1 over x. Making sure we're awake. Okay, cool. That's it. So I take either of those, but if the directions did say to simplify, you need to put in the second one. Okay. Can't talk too much about simplifying rational expressions. Okay. So that's it for those. Things get a little hairier though, right? When you don't have the same denominator, right? So remember in middle school, if two fractions didn't have the same denominator, you had to manipulate them to make sure they did, okay? So here's what I think is the best way to do this. I'm going to rewrite this one on the left. I'm just going to call it the pink fraction. This one on the right, I'm just going to call it the orange fraction, okay? Hey, Lauren. Okay? So we need to get them to have the same denominator. cold with us? We need to get them to have the same denominator. Okay? Here's how I've been explaining how to do this. Okay? So you look at all the factors. So make sure everything's factored. And so I'd say just like start by factoring everything. These are both already factored though, okay? And then ask yourself, what's missing from each denominator? What factor is missing? What factor is missing from each denominator that I have in the other? Okay. You'll be able to understand that question. I'll leave that up, sorry. You'll be able to understand that question a little more once I actually do this first problem, okay? So let's get that written down. Got written down. Let's see what people are writing. Okay. So this other one, right? So what I need to do is I need to multiply the top and bottom of this pink fraction by something that makes these two fractions have the same denominator. So here's what I'm asking myself. I have an 11 here in the bottom and a 7x here in the bottom, okay? What is the pink denominator missing that the orange denominator has? Well, 7. It's missing an x and it's missing a 7, right? There's no 7. So I need to multiply the top and bottom of this pink fraction by 7x. And it gives me 21x over 77x. Okay. Now, what's missing from the orange fraction that I have in the pink denominator? Just 11, right? So I need to multiply the top and bottom over here by 11. It gives me 22 over 77x. Now, what do we notice? They have the same denominator. Okay. So let's do the second one the same way. I'm going to have that pink fraction on the left. I'm going to call the one on the right the orange fraction. Okay. The pink fraction, what does the pink fraction have? Wait, sorry. What does the pink fraction missing that the orange denominator has? Y squared. So how do we get this to be y squared down here? We're going to multiply the top and bottom by y. 6y over 7y squared. Okay. What is the orange denominator missing that the pink denominator has? A 7, right? We don't have a 7. So we need to multiply the top and bottom of the orange fraction by 7. Okay, now do we notice we have the same denominator now, 7y squared. Yeah. Okay. Guys, a couple seconds. Move on to C. Move on to C, okay? We forgot, sorry, I've been forgetting. Make sure, right, we're going to have our pink fraction on the left. Orange fraction on the right. We need to make sure we factor everything. So what do the top and bottom of the pink fraction factor to? The 5's just 5. What does the bottom factor to? 3 times x plus 3. Good job. What about the orange fraction? Top can't factor. What about the bottom? Pull a 5 out. Okay. Good. So we got our two factored fractions here. Let's look at the pink denominator. What is the pink denominator missing that the orange denominator has? So it's missing a 5. There's no 5 over here, and it's missing a what? It's missing it. So we're talking about the entire, so we're talking about the stuff in parentheses. we're talking about like what's missing is the entire factor. So this pink denominator is not just missing a -3, it's missing this entire factor. It's missing an x minus 3. You see that? So we need to multiply the top and bottom over here by 5, and by what? And by x minus 3. It's missing that whole thing. Okay? So that gives us 25 times x minus 3 all over 15 times x plus 3 times x minus 3. Okay? And on that same note, you guys should be able to tell me, what is my orange denominator missing that my pink one has? So it's missing a 3, right? What else is it missing? An x plus 3, yeah? So I have to multiply the top and bottom by 3 and by x plus 3. So that gives me 21x times x plus 3 all over 15 times x minus 3 times x plus 3. Now we know we have the same denominator. We have the same denominator, we're done, okay? Good. These two. You guys should crush this one. Can I factor the top or bottom of the yellow or the pink fraction at all? No, so I'm just going to copy it down. Put the top and bottom are prime. Well, they can't be factored. What about the orange fraction? Can I factor the top or bottom at all? That's a no. Yep. So then let's look at this. What is my pink denominator missing that my orange fraction has? X plus 3. So we need to multiply the top and bottom here by x plus 3. Okay? So we have 4 times x plus 3. Then what's the orange denominator missing that the pink denominator has? X minus 3. So let's multiply the top and bottom by x minus 3. Good stuff. My denominator's the same now? Yes. We're done. Done. All right. I'll move on to part E. I'll get into this second. Good. Let's move on to part E. We got 3 of them now. So when there's 3, instead of like asking yourself, what is my denominator missing that the other one has, you have to ask yourself, what is my denominator missing that the other 2 have? It's just the only difference, okay? So let's highlight this one on the left. Let's call it the pink fraction. Can I factor the top and bottom of my pink fraction at all? The bottom is a 6. What's in the top is a 6. What's in the bottom? I'm dead inside. What's in the bottom? What kind of factoring problem is that? Difference of squares. Difference of squares. I think we're on the right track. What does that factor to then? Yeah, so x minus y and times x plus y. Okay. That middle fraction. The 5 doesn't factor. What does the bottom factor to? I don't know if we talked too much about this one. You're on the right track. So when I see a trinomial, this is a trinomial, 3 terms, right? When the first term is a perfect square and the last term is a perfect square, all right, you should start to think, okay, this might be what's called a perfect square trinomial. I don't know if we hit this.
We did talk about it just earlier.
We did, yeah, we did talk about it. Okay, so we confirm that it's 1. because the middle term equals the square root of x of the first. So we have x squared plus 2xy plus y squared. Right? Write down the square root of the first term. Write down the square root of the last term. If the middle term is x, or these two multiplied together times 2, and then your factor, to factor it, you just write, your shell is just one parenthesis with a square. You copy down this first sign, and then it's just x plus y, the two square roots just copied in there. Okay? So in general, a squared, I'll do this with x and y. Okay, so that's a little review of perfect square trinomials. So our denominator here in our orange fraction factors to x plus y quantity squared. Okay, and then the 1/8 does not factor. So I'm going to call it the green fraction. Okay, now we proceed. Okay, so what's missing from my pink fraction that my other two fractions have? So there's an 8 missing, so we'll need to multiply the top and bottom by 8. There's also one other thing missing. Yeah, so it needs to be a square. This has an x plus y squared. We already have one x plus y here, so I multiply the top and bottom by what? Just x plus y. Yeah, so this gives us 48 times x plus y all over, what is that? 8 x plus y quantity squared times x minus 1. Good stuff. Okay. And then let's talk about what's the orange denominator missing that the other two have. It's missing an 8 and it's missing an x minus y. So we need to multiply by 8 times x minus y over 8 times x minus y. That gives us 40 times x minus y. Good stuff. And then what's the green denominator missing that the others have? Yeah, so it's missing this x minus y that's over here, and it's missing the x plus y squared. So we need to multiply the top and bottom by a lot. We have to multiply it by x plus y squared and x minus y. Okay, so that green fraction becomes job. Okay, now look, it's a big denominator, but they're all the same finally. All the denominators are the same, so that's our answer. Hey, you guys feel okay about that? It's a lot. It's big, it's a big problem, but it's the same process. Okay? That's how mathematicians are able to do hard problems. They just follow the same simple steps every time. Move on? Okay, we move on. Okay. We got these 7 problems we should be able to get through. Okay. So now we're just going to do exactly what we did up here, right? But we're going to actually do the subtraction, okay? So when I subtract 2 fractions, I need to make sure they have the same what? Denominator, right? We just practiced getting the same denominator up here, right? So can we factor this pink fraction at all? No, so let's copy it down. Can we factor this orange fraction at all? No, so we'll just copy that down. Okay, so what's missing from our pink denominator that the orange denominator has? 5, yeah, so we need to multiply the top and bottom of this guy by 5. That gives us 25 over 31. What is the orange denominator missing that the pink denominator has? 6. What's not forget we're trying to subtract. Don't forget that minus symbol. Okay, so what do I do now? This is the easy part. You just subtract across the top. So I have negative 29 over 30y. Final answer. Note here, if they ask you to simplify, you can't cancel anything, but y equals 0 would be excluded. B, can we factor the pink fraction? That doesn't factor. What about the orange? No. So what is the pink denominator missing that the orange has? So it's actually, okay, so it's actually not missing anything because what the x squared is just x times x, so it really just has two x's, right? So it's not missing anything that the orange has. The orange is missing what though? Right, we need another x over here, right? So we have to multiply the top and bottom of the orange by x. So we get 7 over x squared plus 3x over x squared. Okay. So I'm talking about like factors. Factors that one denominator has that are missing from the others. Then what do I do at this point? This is the easy part. Just add across the top, right? 7 plus 3x. What's that? It's just 7 plus 3x. They're not like terms. We don't combine terms that are not like to each other. Okay, so that's my final answer. I can't simplify, but do note, what would my excluded value for this one be? If I set the denominator equal to 0, what's that solution? 0, yeah. X equals 0 would be excluded. Okay. We're doing good work so far. We're doing a good job. C, can I talk about C? C, so we got this pink fraction on the left here. Can we factor that at all, top or bottom? What about this fraction on the right, the orange? Can we factor that at all? Nah, okay? So let's ask ourselves, what factor is missing from the pink denominator that the orange denominator has? So not just a minus 2, right? We're talking about the whole factor, so it's missing r minus 2. Does that make sense? So we need to multiply by r minus 2. Yeah. Okay, don't forget you're doing plus. What's missing from, now what factor, I should say, what, right? Because both denominators have an r. But r and r minus 2 are not the same factor, right? What factor is missing from the orange denominator that is present in the pink denominator? R, yeah. So we need to multiply the top and bottom, this guy by r. So we get ar over r times r minus 2. Now look, they have the same denominator. This is the easy part, right? What do? Just add straight across the top. And let's combine like terms up here, okay? Let's combine our like terms in the top. So we'll distribute. This is like one of the few times you distribute in these problems. Right, what am I excluded? So we need to make sure, let's factor the top then. We need to make sure we simplify. So let's factor the top. I can pull it at 2, right? 2 times 7 minus 6. So nothing cancels here, but what are my excluded values? Yeah, so positive 2 and what? 0, yeah. There's my answer. Good job, guys. I'll give you guys a couple seconds to finish writing that down. move on. D, let's talk about part D. Okay, can this pink fraction on the left be factored at all? Can the top or bottom be factored? No. What about the orange fraction on the right? Can the top or bottom be factored? Nah. Nah, okay? This one's a little different. So, right, these two factors here, right? If we ask ourselves, what factor is missing from the pink that the orange has? You might say 4 minus x, right? Okay. This is a little tricky. There's just a little algebra. Instead of like multiplying the top and bottom of this by 4 minus x, there's a little algebra trick we can do to turn this into an x minus 4. How do we swap these around? How can we swap those around? Does anyone know? Yeah, we can factor it. It's called factoring out a negative. Factor out the negative. So, okay. So 4 minus x equals negative x minus 4. Or negative 1 times x minus 4. Okay? So what we can do here, all right, I'm just going to copy down the pink fraction. And then it's going to be a minus, okay, minus 1 over negative x minus 4. Okay? You see that? So now they have the same denominator. This just becomes 1 over x minus 4 minus negative 1 over x minus 4. Okay? Minus and negative is just the same as plus a positive. So what's my final answer? They have the same denominator. This is the easy part. 2 over x minus 4. Okay. So when they're almost the same, right? When they're just off by like, they're almost the same. They're just flip-flop with the subtraction. If it's a plus, you don't have to do anything to flip it. But if it's a subtraction, you have to multiply by negative 1 to swap them around. Are we feeling okay about that one? I feel like that was a little wand waving. That's what we used to say in college. He was doing some wand waving. All right, and then we can't simplify this one, but what is the excluded value? Yeah, x equals 4 is excluded. Good stuff. Good stuff. Okay, 3 more problems. We'll get through these. Okay. Can I factor this pink fraction on the left here at all? Yeah, so let's factor that. Top doesn't factor, the bottom factors. It factors 2. I'm going to whip through this. Plus, minus, what is that? That's 6 and 2. Okay. What about this orange fraction? Does that factor at all? Top doesn't factor. Bottom factors 2. There's no GCF, so I can't pull that out. 6 and 8, right? Okay. Let's ask ourselves, what is missing from the pink denominator that the orange denominator has? Just x plus 8, right? So we need to multiply the top and bottom of this by x plus 8. Good. What's missing from the orange denominator that the pink denominator has? X minus 2, right? So we need to multiply the top and bottom by x minus 2. Now look, we have the same denominator. So what's the easy part here? Yeah, we gotta add. So we have x plus 3 times x plus 8 plus 3x plus 2 times x minus 2 all over x plus 6 times x minus 2 times x plus 8. Okay? You guys are going to hate me, but we need to take the numerator, so I'm going to highlight the numerator. We need to take the numerator and put it into standard form, then factor again, because we need to simplify our answer. Right? So at this point, we can get our excluded values. We just don't know if anything cancels. We have to expand these out. First, outer, inner, last. our like terms on top combine to 4x squared plus 7x. What is that? Plus 20? Let's see if we can factor the top. Can we factor the top? I don't think we can factor the top, so we're done. So this is almost simplified. What are my excluded values? Good job. Excluded. Okay, cool. How are we feeling? Are we following? It's the same steps every time, right? There's just a lot of factoring to do. Yay. But you get really good at factoring over time, I promise. Okay? You got this. Here's a three-er. Here's a trio. Pink fraction factor at all? Nah, it does not. So let's not forget we're doing plus. Does the orange fraction factor at all? No. Does the green fraction factor? Yeah, there's a minus here, don't forget. Factors to x plus 1 times x minus 1, right? It's a difference of squares. So what is the pink denominator missing that the orange and green have? X minus 1, yeah? So we need to multiply the top and bottom by x minus 1. So we have 7x times x minus 1 all over x plus 1 times x minus 1. Right? What is the orange missing that the other two have? X plus 1. So we need to multiply the top and bottom here by x plus 1. So we have 8 times x plus 1 all over x minus 1 times x plus 1. Is the green missing anything that the other two have? It's not. It's not missing anything, right? Do we see how it's not missing anything? Okay. Oh, yeah. So look, these all have the same denominator. So this is the easy part, right? We add those first two. Subtract that 14, and then it's all over the common denominator, just like with regular fractions. Okay, you guys are going to hate me, but make sure you expand the top and combine everything. Okay. We know what our excluded values are going to be. What's that going to be? Yeah, it's going to be excluded. And then let's see, can that top be factored? It can be. Woo! So what is the top factored to? Set up our shell. Signs are a plus and a minus. At least it's prime. At least the first number's prime. That'd be what? Trial and check. These two, right? 7 times 1 and 6 times 1, right? 7 times 1 needs to be positive. So it's going to be 7 and 1, and then 1 and 6, right? Did I factor that correctly? Yeah, sweet. And then what cancels here? X plus 1's cancel. So our final answer, we just keep these two. 7x minus 1 all over x minus 1, okay? Good stuff. So let's do the 6.2 homework for tomorrow. Hey guys, great work today. We won't get to this last one. That's fine. It's very similar. Okay, so this is kind of tough, guys, okay? So come in for extra help if you need it.